In this problem, we are looking at perimeter. So luckily, perimeter is pretty straightforward as far as we just add up all the sides. So we don't have to come up with like, oh, how do we split this up to find the area? That would be a real pain. We're not doing that here. We're just trying to find the perimeter. And what we notice is that there doesn't seem to be a lot of information given to us. And maybe you're even thinking we don't have enough information to solve it, except here's what I'm going to do. I'm going to imagine that these walls can move and that I can move this side right here up. And I can move this side right here over. Now, if I just move those around a little bit, I haven't actually changed the perimeter in any way. So if I clear this, what I can do is essentially turn this into that shape right there. And these go away. And the same thing over here. I can take this one, and I can move that one up, that one over, and we end up with, sorry, it's not working, here it is, with that shape right there, and these sides are gone. So the perimeter of this weird octagon is the same as it would be if this was a big square, because now this 8 got transferred over, so that's 8. So the full length right here is 20. So this side's going to be 20. This side up here is going to be 20. So that is, at least in my mind, kind of the simplest way of thinking through this. But you can also look at this. You know that this segment right here, and this segment right here, whatever lengths they all have to add up to 20. So that's maybe one way you can think about it. Okay, so bottom line, 20 plus 20 plus 20 plus 20 is 80. The answer is B. Okay, if you made a mistake, hopefully you can catch what you messed up with in your thinking. And there we go. So today with this, we're just doing some practice with all the different volume formulas. And there's just a PDF. So you'll notice in the presentation, I don't have anything else. There is a PDF in Canvas, and I'm going to pull that up real quick. I'm actually going to share this, if I can find it. There we go. I'm going to share this. Okay. Now, I believe in your homework, what I assigned you, it's been more than a couple minutes, so I'm trying to remember. You have 2 pages. The second page has 4 problems, and I highly encourage you guys to try these 2 down here. But what you have to do are these 2 right here. That's part of your homework. So we'll come back to this in a second. But we've got some spheres, and notice right here, this is not a complete sphere. Does anyone know what we call this if it's only half of a sphere? You have heard the word. It's called a hemisphere. So when you think of the northern and southern hemisphere, that's what it's referring to, half of a sphere. So there it is. You can find the hemisphere. I'm not actually going to go through and do the math on this, do this problem, but obviously you learned the formula for the volume of a sphere. If you know that this is half of it, then find the total volume as though it's the full sphere. And whatever number you come up with as your answer, then just divide that by 2. And there you have the hemisphere volume. So if you have questions on that when you get to it, if that doesn't make sense, certainly let me know. And I just want to reiterate, if you don't have a question right now, but you're working on this later and you can't solve it, and a question comes up, feel free to show up in class the next day and ask questions about that. So if you have any questions on previous homeworks that you weren't able to get an answer for, feel free to stick around and we can look at those problems. A couple of these I want to point out, and you're going to notice, well, look at all of these except for, well, let's start with this cylinder right here. Notice the cylinder does not give you the diameter or the radius. Instead, it gives you the circumference. So this is something you might want to remember. And I did give you these formulas at one point, but the circumference of a circle is 2 pi r, and the area is pi r squared. So if they give you the circumference, this value right here can actually get substituted in, and you can go and reverse engineer, solve for the radius. And once you have the radius, then you can solve for the area. So I just want to kind of verbally walk you through that you know, to that extent, and see if you can figure it out from there. So if you want to take a screenshot of what you've got right there, that can help guide you through it. But I'm not actually going to do that particular problem. Now I'm going to clear this. And for the rest of these up here, notice that they're all pyramids or cones. And in every case, you are not given the height of that pyramid slash cone. We don't know this distance right here. We don't know that distance right there, or this height, or this height. They're all unknown. So we're going to have to do a little bit of extra math in order to figure out what the height of this pyramid slash cone is going to be. So it doesn't matter which one I do. Let's just start with the first one right here. If this is what I'm working with, then the volume of a pyramid is area of the base times the height divided by 3. The area of the base, because this is a square pyramid, and we can see that. This is one of those examples where the pyramid's actually flipped upside down, so the base is on top. And typically that doesn't happen. I might have promised that you wouldn't see one, and I forgot that we had problems like this. But it's still pretty easy to tell where the base is on that pyramid. All right, so the area of the base, because it's a rectangle essentially, is going to be base times height. What is the base and height of this rectangle, this square? Yeah. No, yeah, go ahead. Were you called? A second. There we go. Because this is a square, we have 16 centimeters for the base. It doesn't matter which one I'm called the base. And 16 centimeters for the height right there. So finding the area of the base is pretty straightforward. In fact, I'm not going to worry about doing this calculation. You should be able to handle this. 16 times 16 is 256. And that's going to be centimeters squared. Okay. So now we can plug that in. That's 256 times the height. But this is where I do not know the height. So what are we going to do with this? And maybe just as a quick thing to say as you're thinking, what's tempting to do is take that 17 and plug it in right here, but the 17 is not the height. That's what we call a slant height. So how do I find that height right there when I know the slant height? Notice what I drew on the screen. What is that shape that I kind of sketched, superimposed on top of the pyramid? Mm-hmm. Can no one tell me what this shape is right here? That is a right triangle. Okay, I'm going to kind of draw this separately. All right, that doesn't look very good, but I know that this is the height that I'm looking for. That's 17 right there. I don't know anything about the angles. So if your first thought is you want to use trigonometry, unfortunately, we don't know what these angles are. But can I solve for this missing side right here with the question mark? What do you think that's going to be? It's not 16, because 16 represents the entire way across. So what might it be instead? It will be just half. Now, I will go ahead and say this is something, technically the highest point of this, called the apex, could be anywhere. So this point right here that forms kind of the tip of the pyramid, it doesn't have to be right over the middle, but we're going to be dealing with what we call regular pyramids. And in our cases, it's always going to be right over the middle, which makes our life a little bit easier. So now that means this distance is 8. So when I go back to this diagram that I created, that's going to be 8. Okay, now what can we use to solve for the height? Pythagorean theorem. All right, I'm just going to write a squared plus b squared equals c squared. And then I'm going to write h equals, because that's what we're solving for. And I'm going to let you guys go through, solve that on your own, and write down what height you come up with. I'll give you a hint. You should get a whole number. There it is. We got 15. Everyone's coming up with 15. That's good. So now we know the height of this is 15. And now we can kind of plug this in, 15. Let's go ahead and solve that real quick. And notice, if you're wondering why I just plugged the 15 right there, what I did is, since we solved for the height is 15, that's the height of my pyramid. So I'm just plugging it in right there, which when I'm plugging numbers in, it goes right there. All right, so that can be plugged into your calculator. And we can go ahead and come up with a final answer for this. Feel free to write that in whenever you've got it. And go ahead, right, there we go. You're writing in the units as well. This is beautiful. There you go, we have our answer. In fact, now we've done one of your homework problems. You will need to turn that in, so we've got it shown right here. Okay. So the question that was asked in the chat, just as a last thing, so saying it could be a 30, 60, 90, and why don't we just use our special right triangle rules? It's a good question. The only way we can use our special right triangle rules is if they tell us what one of the angles is. This will be close to 60 degrees. In fact, I can tell you right now, this is going to be 61.9 degrees. But it's not 60 degrees exactly. So we can't use any of our special triangle rules, special right triangle rules. But there are going to be problems. I'll go ahead and clear the screen now. And if I zoom out, actually I don't need to zoom. This one right here, notice it's a similar thing where we've got the height that's unknown, but we also don't even know the radius right here. All it tells us is the slant height. But it does let us know this is 30, which means that's 60, that's 90. This is a special right triangle. You can choose to use trigonometry to solve for the missing side lengths, or you can use your special right triangle rules. But that's because it tells us this is 30 degrees. All right. Well, we didn't divide 17. When we were right here, we were dividing the 16 in half. So this length right here represents half of the 16. All right. Okay, so you have the rest of this to do. Remember, you only have to do the top 2 problems here, but these are composite, which means you need to get the volume of each one of these prisms / pyramids or spheres and cylinders. You need to get each one and add the total volume together. If you run into any problems, feel free to ask me questions. If you have questions right now, stick around. If you're good to go, you have the rest of the class period to work on this. And I will see you guys tomorrow.